In this geometry series, we'll take a look at angles, take a look at areas and volumes, all things that get used a lot in describing properties and attributes of physical systems when we're looking at engineering problems. First, we'll take a look at angle properties. Now, in a different series, in trigonometry series, I've already gone over the difference between degrees and radians, and we talked about the unit circle. I'll put a link to the videos that I think could be useful if that's what you're looking for in the description below. But in this video, we're going to take a look at angle properties, what happens when we have intersecting lines, how we can equate angles. This gets to be very useful when you're looking at building physical systems and trying to relate components that are normal to each other or parallel to each other. So we can start with the basics, right? When we talk about an angle, we're talking about the property between two lines. So here I have blue lines as horizontal, and I can place another line attached to the left corner of these blue lines and adjust it at different angles. That's what we mean by angles, right? So if one line is horizontal and the other is vertical, we call these right angles, and these are 90 degrees. So 0 degrees would be if it was just stacked on top. 90 degrees is if it's vertical. If we lay it across the side here, this will be considered 180 degrees. So a straight line we look at as having an angle of 180 degrees. If we point this red line down and take a look at the angle across here, this is 270 degrees, right? So 90 degrees is actually very useful, right? So 90 degrees here plus another 90 degrees here gave us 180. 90 here plus 90 here plus 90 here gave us 270 degrees. You can also notice that if you have 270 degrees here, this right here down here is a right angle. This is also 90 degrees, just like we have up here. It depends which part of the intersection of these two lines we are looking at to find the angle of. And if I have one line stacked on the other, we can either define this as 0 degrees, or we can define this as 360 degrees, right? So these are the four main angles that we look at when we look at trigonometry, or in this case, geometry. Now there's a couple of other important angles that show up a lot. So 30 degrees, 45 degrees, and 60 degrees. In another series of the trig videos, we talk about 45 degrees as the angle of an isosceles triangle. So a right triangle, right, with one angle is 90 degrees, and the other two angles are 45 degrees, has two sides of the same length. That's what we mean by isosceles. If we have a equilateral triangle, all three sides are equal, then we know that all three angles are equal. That's when we have the 60-degree triangle, or equilateral triangle. So that's why 60 degrees is a really important angle. And then if we split the 60 degrees in half, so then we have an equilateral triangle, and cut it in half, so we have a right triangle, two right triangles. That's when we saw 30 degrees show up. Right, so these are all these 7 angles are typically the ones we start with in trigonometry. Also, they're very important in geometry. So the next thing we're going to take a look at is we're going to look at the straight line with 180 degrees. We'll look at some properties of intersecting lines. So we said if we have two lines, one pointing one direction, one the other direction, we can define this angle as 180 degrees. If we stack the lines on top of each other, we can define that angle as 0 degrees or 360 degrees. Now, we can either call this two separate lines, or we call it one single line. And we could say the angle of a single line is 180 degrees, right? It depends on how we draw that angle component, or what we're actually trying to represent here. So if I know that a straight line has an angle of 180 degrees, then I can put another line on top of this straight line. And I know that is also going to have 180 degrees. Now, what I want to define here is the relationship between these four angles that get created. So once I put two straight objects or two straight lines on across them, then I create four angles, right? So I got one angle right here between the orange and green, one angle here from the orange to green here, one angle here from the green to orange, and one angle from the orange to green here. The two things I know is if I add this angle to this one, I get 180 degrees because of this green line's relationship. And what else do I know? I know that 180 degrees is the angle of this orange line as well. So the angle of this value, this angle here, plus this angle is also 180 degrees. So we can start defining some of these things, right? So if I call this angle alpha, and I call this angle beta, because this straight green line has an angle of 180 degrees, I know the sum of alpha and beta will be 180 degrees. Okay, then I look at this orange line here. I know that beta plus whatever angle is right here between the green and orange here will also equal 180 degrees. Well, if this unknown angle plus beta is 180 degrees and alpha plus beta is equal to 180 degrees, that means this must be equal to alpha. And then similarly, we can say if this is alpha, then this unknown angle here, alpha plus whatever this angle is here, will equal 180 degrees, right? So 180 degrees up here is also 180 degrees down here. So we know this angle is equal to beta, right? Make sure this makes sense. When you cross two lines, the opposite angles, right, up here and down here are equal to each other. That's the beta and beta. And then the opposite angles, alpha and alpha. All they have to be are straight lines that intersect. Okay? They don't need to be at a certain angle. It doesn't matter. I exaggerated here because beta obviously is a larger than 90-degree angle, so it's obtuse angle. And the alphas are much smaller than 90 degrees, so we know those are acute angles. All right. So the next thing we can do is we can throw a parallel line. So parallel line means the line we basically grab and just shift vertically or horizontally. We don't change the angle of the line itself. So this green line down here is parallel to this green line up here, right? That means if I place the green lines near each other, they can stack right on top of each other, right? It will either be 0 points intersecting as it is here, or if I put it right there, it'll be all the points intersecting. If we look at this orange line and this green line, since they are not parallel, they will intersect at one and only one point. Okay, so that's the definition of parallel. Now, if I have parallel lines intersected by a third line, this orange line, then I can define the relationship between all the angles that are created. So we said earlier that when I have two lines intersecting, right, this top green line and this orange line here, I get four angles that are created. Well, essentially we get the same four angles created here. So we have 8 angles total when I have two parallel lines intersecting with a third line. So how do we think through this problem? Well, if this angle is alpha, I know that this angle must be alpha. How do I know that? Well, if these lines are parallel, I can shift this green line all the way up here, and it's basically the same thing, right? As I move the line vertical, I don't change the angle. There's no change to that angle. So if this is alpha, I know that opposite angles must be equal. So those are both alpha. If these are both alpha, I know from the definition that a straight line has an angle of 180 degrees. That means this angle alpha plus whatever this angle is must equal to 180 degrees. So that must be beta. If this is beta, I know opposite angles of intersecting lines must be equal. So this is beta, this must also be beta, right? So when you draw, and this is a typical first kind of problem for geometry problems, is you have two parallel lines, you're going to have intersected by a third line, you're going to have two types of angles, right? You have alpha, 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 and then you have beta, 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 beta. This becomes very useful, and we'll use it in defining different kinds of shapes and defining the angles. And then once you get to trigonometry, you can relate those angles to relationships between the sides of those of that shape.